Hello, everybody, and welcome to our third lesson of Chapter 6, Proving Identities. A note that there is one more section that will be posted if you would like to try that as well. But for this purpose of our e-learning at home, this will be our last section. This is also the hardest section of the chapter. So generally people have a hard time because I'm sort of switching the rules on you a little bit here. Well, not me, math. And so if you are planning on taking more math, you will see this word prove a lot more if you plan on taking more than just calculus at university. Um, I think proving's a lot of fun. I think this section's a lot of fun. But if you ask people who've taken Math 12 already, they might disagree with me. um, you're going to need your formula sheet. Please have that out. This will most likely be a longer lesson because I am going to go as slow as I possibly can. If I'm going too slow for you, feel free to skip ahead or speed up the video, because I'm going to try and make sure I talk through every single step that I do, because it does tend to be a section that people get a little lost in. What we're going to be doing today is doing something called proving identities. So to prove that an identity is true for all permissible values, our goal is to express both sides of the equation in equivalent forms. In other words, we're trying to make both sides of the equation equal by viewing each side as a separate expression. What that means is we are not going to move anything left and right across the equal sign. So as soon as you see this word prove, this means you are going to work on the left-hand side and right-hand side of the equal sign separately. You will not move things from left to right across the equal sign. Okay? So work on the left and right side of equal sign separately. Do not move things from left side to right side and vice versa. Okay? You are going to treat each side of the equation as an independent expression. Okay, so you're going to manipulate the left and the right side so that they become equal to each other by using math you know how to do and identities. So manipulate each side separately using identities and math tools you already have. Okay. Also, a reminder when you're dealing with expressions, if you want to manipulate things like denominators of fractions, you must multiply by something that equals 1. So when I say you cannot work on both sides of the equation, you can work on both sides separately, but you can't do things like, oh, I'm going to multiply the left side by 2 and the right side by 2. That doesn't work in a proof. What you can do is you could multiply one of the sides by something that is equal to 1. So you could multiply one of the sides, or both sides, I guess, but you wouldn't want to, by 2 over 2. So you can't just multiply things by 2 or just divide things by 5. You have to be multiplying by something that equals 1. Okay. So we're going to go through a couple different scenarios of tools you will need to be able to do these proofs. So each example is going to have a sort of a separate set of tools you will need, and I've tried to include each type possible in these notes. Okay. What I like to do when I do my proofs, I'm going to draw in the question here. Is I draw myself literally a line down the middle. Oh, that's a very sideways line. Let's try that again. That's a bit better. Okay. So I'm going to draw my line down the middle, and I'm going to treat this like a brick wall. I cannot move things across the brick wall. I'm allowed to work on the left of the brick wall, and I'm allowed to work on the right of the brick wall. And my goal is so that both sides will eventually be equal. I cannot move things across the brick wall. If it helps, you can literally cover up one of the sides and only work on the other, and vice versa. We are still allowed to manipulate both sides, but we must do so independently. Okay. So again, my goal is to try and rewrite everything in terms of sine and cosine to start. So on the right side, I have a cotangent. I don't want a cotangent. I want to rewrite that. So on the right side, I'm going to rewrite this as sine x cosine x. And I'm going to change my cotangent to cosine x over sine. Okay. Now, again, on the right-hand side, a reminder that sine x cosine x, technically these are over 1, which means that the sine from the top and the sine from the bottom cancel out, leaving me with cosine x times cosine x, or cosine squared x. Now, the two sides don't equal, but I can't simplify the right-hand side anymore. So what I'm going to do is I'm going to go back and look at the left-hand side and see if there's anything I can do there to make it equal cosine squared. And there is. This is my Pythagorean identity. It just straight up equals cosine squared x because of my Pythagorean identity. Okay. So then I'm done. I like to put a little check to show that I've finished so that I know when I go back to look at my question, I don't have to keep going. If you're taking formal math, they might also use a little hashtag to show that the proof is done, or they will write the letters QED, meaning we're done. Okay. So the little check mark is not formal. It's just what I like to do. But if you are taking more math, you'll see the hash mark or you'll see QED. Okay. This would be a basic proof. And the skill we used here was changing things to sine and cosine using reciprocal or quotient identities, as well as pulling out our information that we know about Pythagorean identity. Okay. Next one. Again, notice it says prove. We're not allowed to work from left to right. We have to work on each side separately. I'm going to draw my wall. Okay. It doesn't matter which side we start with. I'm going to start with the right. It looks worse. And I'm going to try and see if I can get it to equal tan x. Okay. So on the top, I know that I'm going to have a double angle identity. And on the bottom, I have a double angle identity. You are welcome to put these identities in at the same time. I like to start with sine 2x because I know what that one is. Cosine 2x, the problem is that we have 3 options. And I don't want to think about that yet, so I'm going to put it off one step. I'm going to change this bottom part only to start. Okay, so this one, we dealt with the sine double angle identity. Now we still do need to deal with the top, and we need to decide which double angle identity for cosine we're going to use. Again, I know the question tells me what I'm supposed to equal. I'm supposed to equal tan x when I'm done, which means that 1 on top should not be there. And my options for cosine 2x are 1 minus 2 sine squared x, 2 cos squared x minus 1, or cos squared x minus sine squared x. Okay, you'll notice this looks similar to an example we did in 6.2. That's because it is. Okay, again, you would need your formula sheet here if you don't have these memorized. That's expected. You do need the formula sheet. I don't expect you to memorize these by any means. Now, again, similar to the question we did in 6.2, if I want to get rid of the 1, this last option doesn't work for me. It's not going to get rid of a 1. I want one of the other two. Similar to 6.2, the first one seems like a better option because I would have 1 minus 1. If I pick the middle one, I'm going to have 1 minus negative 1, which does not get rid of the 1. So I'm going to choose the first one. Again, if you chose a different one, it's not wrong. It's just going to result in more work for you. Okay? The more questions you do, the better you will get at picking which one to use. I still sometimes don't pick the right one, and I'll sit there doing my question thinking, man, this is taking forever. And that's kind of a hint that I probably didn't make the best choice at the beginning, but I will get to the right answer eventually. It just might take me a little longer. Okay. So now I'm going to expand the negative into the brackets here. Okay, you get 1 minus 1 plus 2 sine squared x all over 2 sine x cosine x. Now I've got 1 minus 1 on the top. My 1's cancel out, which leaves me with 2 sine squared x over 2 sine x cosine x. And now I have a 2 on the top and the bottom. Those can cancel. I also have a sine x on the top and the bottom. So one of the ones from the top will cancel with the one on the bottom, leaving me with sine x over cosine x, which also equals tan x. My wall was not long enough, and I am done because the question said on the left side it equaled tan x. Okay. So just some strategies here for you. I like to manipulate the more complicated side and start with that. I try and rewrite all of my trig ratios into sine and cosine only. Sometimes that's enough, like the ones we just saw. Now, sometimes by this point, we still are not done. Our two sides are not equal. So we have two other tactics here we can use, which I'm going to show you in the remaining two examples. One of the options is to multiply the numerator and denominator by the conjugate. Now, a reminder, if I have something like 5 over 1 minus root 3, my conjugate is 1 plus root 3. Okay. Now, in these questions, we don't have roots. We have sines and cosines, but the conjugates work the same. So you'll see at the top, bottom of my screen, at the top of your notes, example 3, we have a 1 minus cosine x and a 1 plus cosine x. So depending on which side of the equation we look at, we would have a conjugate where instead of having 1 minus, we'd have 1 plus, or instead of having 1 plus, we'd have 1 minus. And that might be the only way we can multiply or fix our expression is multiplying by the conjugate. The other option, which is option number 4 in your list above, is to factor. Sometimes you'll get stuck, but if you factor, you'll have common factors on the top and the bottom of your expression that can be canceled out. So we're going to, for example, 3, we're going to use method number 3 using a conjugate. And for example, 4, we're going to see how we can factor to simplify. A reminder, you cannot cross multiply. We have to work on the left and the right separately. So when you see a question like number 3, first I'm going to draw my wall. Okay. What will often happen when you need to use a conjugate is they kind of look the same, but like upside down and backwards is how I like to think of it. So on the left, the sign's on the bottom, but on the right, the sign's on the right. And then one of them has a plus, one of them has a minus. So they look really similar, but they're not equal. They're not quite the same, but it looks like they should be. There's something about it that seems like we should be able to make them equal. And so what we need to do is we need to multiply by the conjugate on one of the sides. Both sides suck here. Neither of them are nice. Pick a side and work with that. I'm going to pick the right-hand side simply because I have more space on the right of my wall. If I use the left side, my writing's too big. I don't have enough space to literally write on the left side there. So I'm simply going to use the right-hand side because I have more room. It does not matter which side you use, okay? So on the right-hand side, if I want to work with this, if I want to multiply by the conjugate, I'm doing the conjugate of the denominator here. And my conjugate of my denominator would be 1 minus cosine x. Now, because I'm working with technically an expression only and not an equation, I must multiply by something that equals 1. Okay? If I had worked on the other side, this would not be my conjugate. If I work on the left, I would multiply by 1 plus cosine x over 1 plus cosine x because that's the conjugate of 1 minus cosine x. Okay? So if you've chosen to try the other side instead, that's fine, but you should be multiplying by something different. Okay? So if I continue here, on the bottom, I want to expand this and I would get 1 minus cosine x plus cosine x minus cosine squared x. On the top, I'm going to leave it factored. Okay, so anytime I'm working with a conjugate, I will only expand the part where I was actually multiplying by that part's conjugate. So on the bottom, I'm expanding it because I'm multiplying by the conjugate of the bottom. But on the top, I'm going to leave it factored because expanding it is not any more simple. It's actually worse. If you do expand it, you're just going to have to refactor it later anyways. So I would just leave the top, okay? Now on the bottom, you'll see that you have a cosine minus cosine. Those cancel. And those middle terms will cancel every time you do a conjugate. So many of you will start to notice if you are going to multiply by a conjugate, you end up with the first term squared, which for us is 1 squared, minus the second term squared, which for us is minus cosine squared. And that's because when I multiply by the conjugate, what I'm really doing is I'm foiling a difference of squares. That's what a conjugate gives us. And when we were doing radicals in Precalc 11, it was so that we could get rid of the radical. For us, it's simply so that we can then use another identity here. Okay. So when I expand my brackets from here to here, on the denominator only, Then I can simplify my denominator so that I only actually have two terms. And again, this will happen every time. So many of you will skip straight from the first step to the third step, and you won't write in that middle step we have here. That's fine. Most of my questions, like if you look at board questions or whatever, if I've multiplied by a conjugate, I will not show that middle step. I will skip right down to the difference of squares denominator there. Okay. Now we see on the denominator, we have 1 minus cosine squared. That is actually your Pythagorean identity. So 1 minus cosine squared is the same as sine squared. So this here, we used Pythagorean identity. All these arrows and writing in red on the side, you do not need to write in your answers. I'm simply writing it here for notes so that you can see what we're doing. But on like some sort of test or assignment or whatever, you do not need these red arrows with these red words here. Those are not necessary. Okay. Now what I would have here is I have a sign on the top and a sign on the bottom. Those cancel out. On the top, I'm left with 1 minus cosine. And on the bottom, I still have a sign. And if we go back, you can see this all on your page at the same time. If you've printed this out, you can see that this is what we started with. So if I go out far enough that we can see it all, we have our two sides are equal and we are done. So conjugate you will need if both sides, they kind of look like they're supposed to be the same, but they're like upside down and backwards. Pick one of the sides, multiply by the conjugate. Only actually expand on the part wherever your conjugate was 4. So on either the numerator or the denominator. The other part, leave it factored. When you expand the conjugate parts, you should get a difference of squares, which will then usually, not always, but usually result in a Pythagorean identity you can replace, which will help you simplify with your other part of your fraction. Okay. So if we had worked on the other side, by the time we were done, it would have equaled the right, but we still would have shown that the two sides are equal. Okay, our work would look almost like backwards to this, but we would still get the two sides are equal when we're done. Okay. So the last one, we are going to use strategy number 4 from our list at the top here, factor to simplify. So if we've manipulated the more complicated side and things don't cancel, move everything into sine and cosine. If things don't cancel, you might need to use the conjugate or factoring. So if we go down to example 4, if we take a look at this, first, we have a problem. We do not have all sines and cosines, and both sides kind of suck. Okay, the right side is worse though. So I'm going to start with the right. And I'm going to change everything into sine and cosine. So on the bottom, I get 2 sine x cosine x plus sine x. On the top, I'm going to leave this for just a minute. Okay. So on the bottom, we can see that there's a sign in both the terms. We're going to be able to factor that out. There's our factoring bit, part of it. On the top, part of the problem is that we need to choose which double angle identity we're going to use for cosine. Because we already have a cosine on top, I'm going to choose the identity that uses only cosines. Now again, if we chose a different double angle identity for cosine 2x, it would still work, but it would be more work. Okay, so this is double angle identities. Both these steps here and here, we replaced cosine 2x and sine 2x with double angle identities. Okay, Now on the top, I'm going to rearrange this. Okay. On the bottom, I'm going to factor out a sine x. Okay. Now on the top, we're going to want to factor this as well. So on the top, I'm looking for two things that multiply to be -1 and add to be, or sorry, -2 and add to be -1. So my two things would be -2 and 1. So again, when I factor this, what I'm going to do is I'm going to split up the middle term to be -2 cos x plus 1 cos x minus 1. Then my first two terms, I'm going to join together and find a common factor. My common factor in my first two terms would be 2 cosine x, and I'd be left with a cosine x minus 1. My second two terms, my common factor is 1, and I'm left with a cosine x minus 1. On the bottom, I still have all the same stuff. I haven't done anything new. So you'll notice most of this is just trying to factor the top here. So when you try and factor the top, if you would like to, you are welcome to change these to say y's and rewrite it as 2y squared minus y minus 1 and factor that. That works as well. I would not change it to x's because there's x's in the question, and then most people will forget to put the cosine back in. Okay, so I have one more step in my factoring here. This means my two factors are 2 cosine x plus 1 and cosine x minus 1 all over sine x 2 cosine x plus 1. So we factored the top and the bottom. Okay, so here I need to factor out a cosine, which is what we did, or sorry, a sine. So what we've done, we replaced our double angle identities. We've rearranged the top so that it looks like a nice quadratic. We factored sine x out of the bottom. And then the quadratic on the top, we've factored that. And now we'll see we have a common factor on the top and the bottom that can cancel out. And we are left with cosine x minus 1 over sine x. Now the question is this what we started with? And the answer is no. And that's because we changed everything to sine and cosine and fixed it all up on the right, but we did not change the left. We need to fix up the left as well and see if this will end up equaling cosine x minus 1 over sine x. So we're going to work on the left side completely separately. So on the left, we have cotangent, which is cosine x over sine x, minus cosecant, which is 1 over sine x. We already have common denominators here, so we can rewrite this as a single fraction, cosine x minus 1, all over sine x, which is what we have at the bottom here. And so we are done. Okay. So in the notes online that I've posted, the 6.3 notes online, this question looks much shorter because I didn't show every single factoring step like this. I showed what if you replace the cosine x's with a y and factor it kind of off to the side and then put it back in. So it looks a bit neater online simply because I didn't show all these steps with cosine x's for the factoring here. Okay, so you have a couple options, a couple sort of strategies up at the top. Follow those, use those to help you as you go through your practice questions. Okay, and so we've got our factoring strategy and our conjugate strategy that we might have to use if simplifying and regular identities don't work for us. Again, The only way to really know if your proof works is if both sides are equal. Okay, so if both sides are equal, then you're done. Your proof is complete. But just make sure you're not doing kind of illegal math, so canceling things out that can't cancel. Okay. Um, Try some questions, practice. There's lots of extra practice for 6.3 posted in the folder online. If you go into the practice stuff folder, there's an extra stuff folder, and there are lots and lots of proofs you can try. If you're finding it difficult, do more of them. Really, the only way to get good at these is practice. They won't come to you overnight. You need to try some on your own to be able to do them. So, again, lots of practice has been put up for you to try. You don't have to do like an entire sheet. You can always pick a sheet and start part of it. But please make sure you try some of these on your own. And if you plan on taking more math other than calculus at university, proofs will become fairly common for you. So, understanding how a proof works is a good idea. Okay.